Here's problem number 17 from section 9.1. We're asked, does this series converge? And if so, what does it converge to? Let's take a look at the first few terms of this series. When n is equal to 0, we get sine to the 0th power of something. And that something is pi to the 4th. That's going to be 1. 0, something to the 0th power is 1. Alright, now the next term is going to be sine to the first power of pi over 4 plus pi, which is going to be 5 pi over 4. That angle is in the third quadrant, and it's to the first power. That's negative root 2 over 2. The next term is sine squared, and again we're going to add 2 pi to pi over 4, which is going to give us 9 pi over 4, or essentially a 45-degree angle again, and that's going to be root 2 over 2, but then squared. The next term after that is sine of 13 pi over 4, again adding another 4 pi over 4 to our existing, to the last term, and this is cubed, and we end up with root 2 over 2. It's a 45-degree angle, this time cubed, dot dot dot. I think it's pretty clear that this series then is a geometric series. Its first term is 1, and the r term, the common ratio, the term that we have to multiply each term by to get the next successive term, is negative root 2 over 2. Now, the absolute value of negative root 2 over 2 is less than 1, because root 2 is like 1.4 divided by 2. That's a number less than 1, absolute value. So because this is true, the series converges. And since it's a geometric series, we know what it converges to. It converges to a over 1 minus r, or 1 over 1 minus root 2, minus a minus root 2 over 2, or 1 over 1 plus root 2, or 1 over 2 plus root 2 over 2, which is 2 over 2 plus root 2, and then if we multiply this by its conjugate, so whatever we do on the top we have to do it on the bottom, we end up with 4 minus root 2 over 2 over 4 minus 2, or 4 minus root 2 over 2 divided by 2, or 2 minus root 2. And that's the answer listed in the back of the book.